Welcome everyone. What we're going to do today is we're going to focus on something called solubility rules. If you look down here at the abbreviations for states of matter, you see the G is for gas, L is for liquid, and then look at these next two. The S is for solid and AQ is for aqueous. When something is a solid, we say it's not soluble in water. We usually have a word for it. We usually call it the precipitate. Now, when something is soluble in water, we use the word aqueous. Aqueous literally means that it dissolves in water. So we're going to be using these designations when we determine, using our rules, if something is soluble or not. Here's a list of the solubility rules. We're going to take a look at them one at a time. Now, the first two rules we can probably combine. And what the rule says is basically if any compound like lithium, it says sodium and potassium, notice it says that they're mostly soluble. They are going to be soluble. The first rule, I usually call it rule number 1, really has to do with not just lithium, sodium, and potassium, but pretty much anybody from group 1. Group 1 are the alkali metals. And what I'm going to add here is we're not going to limit this just to lithium, sodium, and potassium. If you are with an alkali metal, any of the group 1 elements, you're always going to be soluble, so you're going to put AQ. It also says that if you are with the polyatomic ion ammonium, so ammonium, which is one of the few positive polyatomics, ammonium compounds are also soluble in water. Now look at the next rule here. The next rule says that if you are with a nitrate, which is NO3 negative, or acetate, so let's put here nitrate or acetate, C2H3O2 negative 1. So any compound that has either ammonium, nitrate, or acetate, the rule is that they're soluble. Now I'm going to go through each rule and break it down. Here's a flow chart combining those first two rules. So according to this, and we can add the other group 1 elements here. So anybody that's an alkali metal, let's include that. They're always going to be soluble, and if it has ammonium, nitrate, or acetate. So let's put a couple of examples here. So let's say I had, let's say rubidium iodide. Okay, let's say I had calcium nitrate or ammonium, let's say ammonium chloride. Okay, or let's say I have, how about magnesium acetate? Well, what all these compounds have in common is that they're all soluble. Rubidium iodide is soluble because rubidium is a group 1 element. So what you're going to write is AQ. That's what you write whenever they're soluble. They're aqueous, dissolves in water. Calcium nitrate contains nitrate. All nitrates are soluble in water, so you put AQ. Same thing with ammonium chloride. Anything with the polyatomic ammonium is soluble. And magnesium acetate, the same thing. All acetates are also soluble. So there's no exceptions with this first rule. Okay, now let's take a look at this next rule. The third rule has to do with the halides: chlorine, bromine, and iodine. Notice fluorine is not part of this rule. Fluorine is not as common as these three. We will focus on these three halides. According to the rule, if you are with chlorine, bromine, or iodine, you're always soluble, but there are three exceptions. The only time that the halides are not soluble is if they are paired up with silver, mercury, or lead. So let's take a look at this rule with some examples. Here's the flow chart. So the way you would ask yourself is, if you have chlorine, bromine, or iodine, ask yourself this question: does it have silver, mercury, or lead? If it doesn't, then it's going to be soluble. But if it does, they're not soluble with those three. So let's put a couple of examples here. Let's say I had copper chloride, zinc iodide, silver chloride, lead bromide. So according to the rule, the first one, copper 2 chloride, that one, as long as it doesn't have silver, mercury, or lead, that's going to be soluble. So you put AQ. Zinc iodide, same rule. Iodide is a halogen. And as long as it's not silver, mercury, or lead, it's also soluble. Now, silver chloride, you could see that the silver being present makes that a solid. So we call that a precipitate, which is a solid in solution. So we're going to put an S there. The S stands for solid. Don't confuse it and think it means soluble. AQ means soluble. And then you got lead 2 bromide. Same thing. The lead is also one of the exceptions here. So according to the rule, this one is also a precipitate. Let's go to the next rule. The next rule has to do with sulfates. According to this, all sulfates are soluble except when they are with the following 4 cations, except when they're with calcium, strontium, barium, or lead. So the flow chart that is set up for you says if you have a compound containing sulfate, as long as you don't have calcium, strontium, barium, or lead, you're going to be soluble. But if it does contain one of those ions, you will not be soluble. You will be a precipitate. Let's take a look at some examples. Let's put here calcium sulfate. Let's put here iron sulfate, magnesium sulfate, and lead sulfate. So when you look at these, the first one you recognize they all have sulfate. So using the rule, notice that if calcium is present, according to the rule, that would be a precipitate. So you put a solid. When you look at iron 2 sulfate, iron is not one of those exceptions. So this one is soluble in water. So you put AQ. When you go to the third example, same thing. Magnesium is not one of those 4 exceptions. So this one is also soluble. However, the last one has lead, and as long as you have calcium, strontium, barium, or lead, you will be a precipitate, so that will be insoluble, which would make it a solid. Okay? Now, let's take a look at this bottom half. This one's written the other way around. You see, normally, sulfide, which comes from sulfur, don't confuse it with sulfate, the polyatomic ion, and hydroxide, they're usually not soluble. The only time that hydroxides or sulfur is soluble is if they are paired up with a group 1 element, which is an alkali metal, with ammonium, okay? And then you'll notice there's a difference. It says you're soluble and slightly soluble, but for simplicity, if hydroxide or sulfur are paired up with the ions calcium, strontium, or barium, we're going to consider these soluble. Although it says slightly soluble for hydroxide, we're going to consider both of these to have the same rule. Let me show you what I mean. Here we have the flow charts for both ions. I believe what you should remember is treat both with this rule. I think this part here is a little bit confusing. So ask yourself this question, whether if you have sulfur or hydroxide, normally they're not soluble. So you ask yourself, does it have somebody from group 1, like lithium, sodium, or potassium? If it does, it makes it soluble. You'll see here in green. Now, if it doesn't, okay, keep looking at the rest of the elements. Does it have ammonium? Is it paired up with ammonium? If it is, it makes it soluble. And then take a look at this. The other three additional cations that would make this soluble, and again, we're going to use the same rule for both. We're going to ignore this slightly soluble here, is if it has calcium, strontium, or barium. So let's put a couple of examples. Let's see, let's put aluminum hydroxide here. Let's put calcium hydroxide. Let's also put sodium hydroxide. And let's put iron hydroxide. So let's use the hydroxide rule. Basically, aluminum hydroxide, you ask yourself, is aluminum from group 1? The answer is no. Aluminum is not ammonium either. And it's not calcium, strontium, or barium. So aluminum hydroxide would be a precipitate. Now let's take a look at calcium hydroxide. Well, calcium's not part of group 1. It's an alkaline earth metal. It's definitely not ammonium. But it is one of the three that the rule says slightly soluble, but I asked you to treat it as soluble. In fact, calcium hydroxide is a strong base, so it is more soluble than, that's why I switched the rule and I told you to treat it as soluble. So because it's soluble, we're going to put AQ here. Sodium hydroxide is also soluble because sodium is an alkali metal. Anybody with someone from group 1 or an alkali metal is always going to be soluble. Now, iron 3 hydroxide is a different story. You see, iron is not from group 1, it's not ammonium, and it's not calcium, strontium, or barium, so iron 3 hydroxide would be a precipitate. Let's do a couple of examples with sulfur. Let's say I had K2S. Let's say I also had here zinc sulfide. And let's put one more here. Let's put strontium sulfide. All right, so K2S, or potassium sulfide, because potassium is from group 1, the rule makes it always soluble. So it's aqueous. Now, zinc sulfide, let's take a look at zinc. Well, zinc is not an alkali metal, it's not ammonium, and it's not calcium, strontium, or barium, so zinc sulfide would be a solid or a precipitate. Let's look at the third example, strontium sulfide. Strontium, if you look, well, it's not an alkali metal, it's not ammonium, but it is one of the three that also the rule says it's soluble. Strontium is right over here. And because it's soluble, you will put AQ. So these are some examples using these two rules that I just showed you. Now we got one more rule. And normally, if you have something with carbonate or phosphate, normally it's not soluble. The only time that these guys are going to be soluble is if they are paired up with somebody from group 1, in other words, an alkali metal, or the polyatomic ion ammonia. If they're not with ammonium or an alkali metal, they're always going to be insoluble. So if you look, this is a very simple rule. Carbonates and phosphates, if they don't have a group 1 element or ammonium, if you answer no to that question, it's going to be insoluble. So let's take a look at a couple of examples. Let's put here calcium carbonate. Let's put iron phosphate. Let's put here sodium phosphate. And let's put here ammonium carbonate. So the first one, calcium carbonate. Calcium is not an alkali metal. In fact, calcium is an alkaline earth metal. So according to this rule, if you don't have an alkali metal or ammonium, you're a precipitate. This is a solid. The next one, iron 3 phosphate, same thing. Iron is not from group 1. It's not ammonium. So these two follow the same exact rule. This is also a precipitate. Now the third one, sodium phosphate. Sodium is a member of group 1. It's an alkali metal. And the rule says that if you're with an alkali metal, you will always be soluble. So this one's going to be AQ. And finally, ammonium carbonate. Ammonium, I kind of treat it like an honorary alkali metal. But anything with the ammonium ion is also soluble. So this one is also AQ. So getting used to these solubility rules will help you, along the way. If you look here, here's a summary of all of them. We looked at them individually, but through practice, you will see that you'll get accustomed to what makes these soluble or not. And this is going to be very important because we will be looking at something called precipitation reactions, in which a solid or a precipitate is formed. And the way you determine if that solid is made is by knowing and applying these solubility rules.